Hello everybody, here's my video on project number 4. To do this, you'll just need to come in here to click on this link, and this link, it'll bring you to the both locations here. So you'll have this simulation that you'll be playing with, and then here's the lab handout that you will be able to mess around with. So with this project, what you're doing is we're looking at a couple things. First of all, we're looking at frequency. We're going to be looking at wavelength, and the last one is amplitude. And so to talk about this just very briefly, so you guys understand, when we're looking at these three things, amplitude and wavelength, if you can notice, are measured by a distance, which is centimeters, okay? And so if I was to draw like a little, let's do it in green because I want spring to be here. All right, so let's say that I have this wavelength, right? So let's say I have this tower here, a telephone tower, and it's sending off a signal. Well, telephone towers, they'll send a signal, and it will follow what we call a wave. And if we were to kind of model this, let's pretend that that's a straight line, okay? And so as we're going through that, we have a couple things. We have a distance right here. We have a distance right here. Okay. And that's what that is. So this one right here, if you can imagine, is your amplitude. This right here would be our wavelength. And so then we have to wonder, well, what the heck's frequency? Well, frequency would be how many times this is occurring in a certain time, right? And if I remember right, frequency is in a second. Let's look that up. Rate of something occurring. That's not really what it is. Frequency of a wave. Let's see if that helps here. So frequency. Okay, so anyways, I guess it depends on what you're measuring. So if we're measuring in hertz here, it would be how many times it happens in a, whatever that equals, one wave passing at a point in 1 second. So it's 1 second is what that is, okay? And so what you'll be doing here is you'll be looking at how many times the wavelength, how many times there is a complete wave in 1 second, and that would be 1 hertz. So kind of interesting there. So anyways, you'll be using this model here to test this. And I'll be right back. Alright, sorry about that. I had to deal with a couple things. Anyways, so with this model, what you'll be doing is you'll be testing these three things. We'll be looking at amplitude, frequency, and wavelength. And so kind of cool. Here's this thing that we can use to do that. We can have a timer, so we can go for 1 minute or 1 second. I'm interested to see what, okay. Anyways, so what we can do is we can it says on here to what to measure. We're going to run a few things there. It says to click the oscillating button. So I'm going to go up here. I'm going to click oscillate. And so here it is oscillating, okay? And what we can do is we can test some different things. So if it's got an amplitude of 0.75, which is what it is, our frequency is 1.50. Can we then determine our wavelength? And we could by freezing it, okay? And if we look right here, let's see how we can measure, wavelength. Okay, so if we look right here at this, maybe this diagram, wavelength is from one crest to another crest. And so when we go over here, we can measure potentially one crest to one crest. So right here, let's pretend that it's right there. We could say that the crest, let's say, is right there. So we could say like, here, let's move it straight at that. 4 inches or 4 centimeters, right? And so I'd be able to put 4 centimeters here and then describe the wavelength. Well, you could draw a picture of that, or you could describe it. Well, it's kind of interesting. It definitely tapers off right here, if you notice that. When it does it say that we can have a loose end? Let's see. No. However, sometimes I wonder if it would help us get that wavelength. There we go. So if we still put it, yeah, so 4 centimeters is about right when it has a fixed end. We see it's kind of interesting to see what happens. I'm going to do it like this because that's kind of how it works. There is no fixed end for a wavelength of what we were talking about. So, but it's kind of interesting to see how it kind of works there. We have our amplitude, but we see amplitude decrease over time when it's open like that. If it's fixed, does the amplitude change? Yes. Okay. And so we can see that amplitude will decrease over time because of that. So kind of interesting there. So you can just do a description or draw a picture of what that kind of looks like there. So you'll do this for each one of these different amplitude and frequency. So you'd have to change those to make it meet that. And then just answer the questions based on what you observe when we're looking at these 3 different terms. After you're done, you'll upload this and turn it in, and you'll be good to go. So if you guys have any questions, don't hesitate to let me know.